Hello students, in the last lecture we have discussed about electric dipole. Now here we will discuss what is electric field intensity due to an electric dipole on its axial position. What is electric field intensity due to an electric dipole on its axial position? Let me tell you what is axial position. Axial position refers that the point is lying in the axis of this electric dipole. Now let us consider an electric dipole consisting minus q and plus q charge. Let a point P lies at r distance from the mean position of the dipole on its axial position as we have considered here. Due to plus q charge, electric field intensity even can be given, which would be outward as we have discussed in earlier, and due to negative charge, electric field lines would be inward as we have discussed. Now let even be the electric field due to plus charge plus q charge, then it may be given as, what is that? We know the formula that E is equal to 1 upon 4 pi epsilon naught q upon r square. So what is the distance from plus q charge? The distance from plus q charge is given like r minus L. What is the distance from plus q charge to P? That is r minus L. So here even can be given as 1 upon 4 pi epsilon naught q upon r minus L whole square. This can be considered as equation 1. Now moving further, and E2 be the electric field due to negative charge, then it may be given as, from negative q charge the P point is lying r plus L distance. It is lying at r plus L distance. So E2 can be given as E2 is equal to 1 upon 4 pi epsilon naught q upon r plus L whole square. This can be considered as question number 2. Thus the net electric field line at point P is given by, what is the net electric field lines? That can be considered as E is equal to E1 minus E2. We are putting the value from equation 1 and 2 here, that E is equal to 1 upon 4 pi epsilon naught q upon r minus L whole square minus 1 upon 4 pi epsilon naught q upon r plus L whole square. Here what we can see that q upon 4 pi epsilon naught is common. We are taking as common, and inside there would be 1 upon r minus L whole square minus 1 upon r plus L whole square. We are solving it out, and what we are getting here, we are getting here that E is equal to 1 upon 4 pi epsilon naught q r 4 r L upon r square minus L square whole square. Here we have opened that a plus b whole square and a minus b whole square as we have learned in previous classes. So let L is very small quantity, then L square would be more smaller, as we are considering L is equal to 0.1, then L square would be 0.001. that is very small. Then it can be neglecting. Now neglecting L square, what we are getting here, that E is equal to 1.4 pi epsilon naught q dot 2L and 2R. We are just bifurcating it 4RL in 2L into 2R. That q dot 2L can be written like P, and R can cancelled out, and here what we are getting, that is your result, that E is equal to 1 upon 4 pi epsilon naught 2P upon R cube. It is the electric field intensity due to an electric dipole on its axial position.